not just analysts and designers, but we also had to be engineers. Now the web is everywhere, and because of that, it's the medium that we definitely target when we're making things, right? Like, you can build visualizations that go into apps, or you can build visualizations that get printed up in newspapers, but if you want to, for free, share your information with other people, the web is the way, right? And now we don't have the problems that we had not too long ago. Everybody has powerful computers in their pockets and on their desks, and more people have them. We can build and deploy these interactive stories that beforehand we couldn't really do, not as well. But the most significant change is the addition of animation, right? It's not just interaction, it's not just I click and bam, all of a sudden it turns into whatever it is that I clicked on. It's that things animate. It's still resource constrained. You can't do animation everywhere. It's hard to do well, particularly for mobile browsers. It's hard to do well on older computers. But Apple created a whole lot of expectations here, right? With the launch of the first iPhone, people started using this and they said, wow, they were amazed, and what the subtext inside this amazement was, oh my god, it's alive, it moves, it animates, it's got soul, it behaves like natural things, and it's not by accident that it succeeded really well. And this created a lot of delight in people's usage of computing. But animation has a lot of practical uses as well, right? Animations show us where things come from. They give hints about how they might behave going forward and where they're going. So it's an additional channel of information for us to use when we're telling stories, and it's sad if we don't use it because we need every one we can get. Now, Apple got really explicit about this when they wrote their interface guidelines for building apps for this new platform, this touchscreen platform. They actually had a whole section on how do you animate this interface so that it's usable, so that it's delightful. Google was a little bit later to the party, but they showed up with a very comprehensive approach to animation in the form of something that they call material design. They launched this less than a year ago. If you haven't yet seen material design in Google's guidelines, even if you don't care about Android or Google stuff and you're a total Mac diehard fanatic, whatever, it doesn't matter. Go read this, because it's one of the more fantastic essays on the use of animation in computing. And they talk not just about things related to Android, but in general, how do we animate things so that they feel natural? You know, not to use linear animation, to use asymmetric animation with easing in and easing out so that it feels like something that we know from the real world. And not just, you know, prescriptive things about how to use animation, but how do we use animation in order to better communicate visual hierarchies, to show where things come from in a fashion that behaves more like the real world. And it's much easier to express ideas with clarity when you can show where things come from, and then it comes from 6 places all at once, it's actually coming from here. Because that's how things usually work in the real world. So in addition to everything from before, animation has become something default that people expect of good interfaces. And now all of a sudden we're responsible for animation on top of all this other stuff that we were responsible for beforehand, and an understanding of how humans perceive images in motion, right? So yeah, our job titles are mutating year by year. So my name is Idan Gazit, and I tell stories with data. I work for a company called Heroku. Who here has heard of Heroku, used Heroku? Awesome. My people. Heroku is the internet's largest platform as a service. I guarantee every one of you that has a smartphone in this room, there's some app on your phone where the backend is running on Heroku. We service something on the order of 5 billion requests a day. We have millions and millions of apps, lots and lots of add-ons and services and blah, blah, blah. None of that actually really matters. What matters is that I get to play with a lot of really awesome data and tell really cool stories. Unfortunately, most of those stories lately haven't been public because they've been internal facing, but it's still a lot of fun. I guarantee you're going to have to take my word for it. And this is a talk about how animation is changing our craft, right? It's a little bit about the people who are making and building and telling these stories, and it's also about the tools and techniques we use to build data stories for the modern web and how they can help us achieve 2 things. How can we expand the boundaries of our ability to tell, to ship more stories, to ship better stories, and to ship stories better. Particularly when it comes to building stories where animation is pervasive, that it's everywhere in the story, that it's not just, ooh, I have a transition between this slide and this slide, but animation is everything. And the second thing is, how are we going to help democratize access to our field, right? It's clear that as time goes on, our job descriptions are growing and growing and growing, and we have to know more and more and more in order to be able to like just pay the cost of entry when it comes to building things that are considered good, okay? So how do we make our toolbox easier to use? Because another thing that's clear is that good data stories are everywhere. And helping people tell their own stories is probably the most impactful thing that we can do in the service of science. If I can help somebody express their whatever to somebody else better, then I've done something good, and I want that to work for as many people as I can. So animation is this huge hurdle, this huge additional thing that we all need to know now, and I want to help newcomers get over that hurdle as fast as possible. Maybe the first problem that we have is getting more people into data storytelling is a marketing problem. We kind of suck at communicating what it is that we do, and by extension, what they're getting into. Like, you know, if you're talking to a student who's finishing, you know, their undergraduate, you know, and trying to tell them, hey, you should come work with data and tell stories with data, what it is that you tell them that you're getting into, I don't know. How many of you work in the field and have trouble articulating what it is that you do to other people in like 2 words, like how normal people describe their jobs? Okay, awesome. I'm hopeful that's like 100% of you, and if there's some of you that you know, then please share your secret. So a friend of mine went to I.O. Festival. I.O. is like a big data visualization festival, carnival, show, conference in the US. And while she was there, she collected the job titles that she saw. This is just a subset. Some of them got really ridiculous. Some of them are practical. Like, you know, they try to tell you what it is that they do. Some of them, not so much. Then there's the ever popular data scientist, right? Everybody's heard about data science. It's like the big thing, data science. This term is so broadly defined as to be almost meaningless. I have no idea what data science is. I don't think that data scientists know what data science is. The only thing that everybody agrees on is that if you call yourself a data scientist, it's like an automatic addition of like $20,000 to your paycheck, right? Oops. Another friend of mine once introduced me to someone as a technical designer. I liked that for a while, I wore it. But the only thing that really binds us all together is that we're hybrids of one form or another, right? We all wear a few different hats in order to get this job done. Which should be like totally obvious since we're supposedly like engineer, designer, software developer, animator, cognitive scientists, which is a real mouthful, right? We need a better, shorter way to describe what it is that we do that other people agree on. So let's look at it from the flip side. How do we categorize the work that we do, right? Ben Fry of processing fame, he famously enumerated the 7 steps of data visualization, right? Acquire your data, parse it, filter it, mine it for information, for meaning. Then represent that meaning, refine it by going back to earlier steps, and add interaction. The problem is that this is a little too high resolution for what I normally want when I'm talking to, like, you know, regular people. I think that what we do breaks down into these 3 basic abilities, right? We have tools and techniques for working with data at scale, okay? And then we have tools and techniques for fishing out some meaningful story, and then we have tools and techniques for turning around and telling that story to other people. That's roughly the 3 sort of like major categories of what it is that we do. And practically speaking, like, you know, if I strip away sort of like the bullshitese, this is what it really comes down to. Like, the working with data is the dirty work that you don't want to do, but you have to, because there's no other way to get at the data. Extracting stories is like the new hotness. Machine learning and algorithms and queries and data sciencey stuff. I actually am not so great at this part. I don't know machine learning. My wife is an algorithms engineer, which is super helpful because that means I don't need to know about it. I just ask her. The part that I usually do a lot of is the third part, the storytelling part, the building the front end, building the thing that's actually shown to people to tell the story. And we think about this in terms of web development and interaction design and information architecture. And animation only affects this last one, right? This storytelling one. And you'd think that it's only like, just adding another line item to that, but it's not. It's actually doubling like that entire category. It's taking this entire category and making it double the work. Because you're adding an additional dimension to everything. The effort involved is not just double, it climbs rapidly if you want to start reaching for, I want this thing to work well for every browser, for everybody, in every place, in every condition. And you want to hit like nice levels of polish. It's not double the work, it's like 1,000 times the work. It's literally impossible right now. And right now you need to also design for all these transitional states. It's no longer that you can show people just like the nice endpoints. You have all these states in the middle, these transitional states, and you have to make sure that those look nice and work well as well. And it was bad enough without animation, right? Without animation, with the web, there's no control. It's not like print, where I know I'm going to have a paper size of X by Y, and I know that I have such and such inks, and I know that I'm printing at such and such resolutions. No, I don't know any of that when I'm designing for the web, right? People are using it like, on a smartphone in daylight, in a train station with like half an eyeball and a thumb. Or maybe they're at home in the dark with like 3 screens of like weird geometries and pixel densities varying. Different OSs and different type rendering engines, right? Because Windows and Mac don't render type the same way. It's terrible. So there are people ingesting your content all over the place, and you have zero control about them. And there's no way for you to force them to look at the nice side of the statue. Okay? You've like put in all this work to make this beautiful thing, and they can like walk around to the backside and look at the ass end of everything. So the storytelling part of the work is growing dramatically in scope. And this is what your audience actually sees and interacts with, so they're starting to develop standards about what's good. And when you look at the web versus native app debate and mobile, pervasive animation is a big part of what makes native attractive. Interaction without animation feels soulless, it feels dated, it's very rapidly becoming a negative thing. And it's hard, if it was hard to find one person to cover the front-end role beforehand, now you're even less likely to find like such a do-it-all unicorn, let alone people who can deliver on the entire part of, the entire pipeline of things that you need to build. If we want to make it easier for newcomers to break in, we need to be honest about the part of the work that we're expecting them to take on, and the part of the work that we expect them to be able to handle. And maybe we need to start thinking about splitting up these responsibilities. When you look at industries that are more mature, they specialize. Industries tend to specialize. When you look at doctors, once upon a time there used to be one kind of doctor. They were called doctor, right? Nowadays there's like 1,000 different specialties, and like my left second toenail is like a funky color. I have to go to like a left second toenailologist in order to get like a valid opinion. So we don't need to go quite that far, but we do need to start breaking up the workflow into smaller chunks and handing them to the right people if we want to actually get things out the door. So getting more people into our field and setting them up for success is great, but what's the state of affairs for those of us who are already here and building things? So this affords the greatest control, right? But it's all the control, all of the headache. And you have to pay this complexity tax over and over again. And with animation, you're paying this complexity tax squared, because you're not just dealing with like, the initial state of how it is. You need to deal with how is it going to change over time, and making sure that you're not going to screw anything up in the middle. And believe me, it's easy to screw it up in the middle. Now on the high level, we have tools that take data and give you back something fully baked, right? Like the Tableaus of the world, or charting libraries, where like, here's some data, I get back a certain kind of chart, either it does what I need, and if it doesn't, well then, I'm screwed. It's not going to work for me, this tool. So these tools tend to be like generic, charts. Like I can have a bar chart like this, or a bar chart like that, or whatever chart, but it's still, sort of one-size-fits-all charts. And the sweet spot for telling custom stories, interesting stories, stories that are not just plain charts, which usually tend to be low dimensionality of information, is in the middle, where we enjoy more control than the high level and more handy abstractions and less headache than the low level. But what do we mean by objects, and why is D3 such a big deal, right? So first, a quick primer about how web content works. The DOM. The DOM is the web, even if you've not heard of it before. What is the DOM? The DOM is a tree. It's a data structure, a tree, that describes the structure of content in a web page. So when you look at a web page, you have a root element, that's the window. And browsers take the HTML that people author and they build this tree for every page that you visit on the web. And once this tree is read in, this tree of the content, the semantic content, you can read this tree and alter it using JavaScript, which is the programming language that works in all browsers. Now if we wanted to add like an image of a chart to this web page, it'd just be one node in the tree, right? I'd add this image, it would go in this place, it would be a node in the tree. That's effectively what processing looks like on the web, right? It inserts an image and then processing can alter the pixels inside that image. It has a little sandbox to play in. But the thing is that all these other nodes in the tree have some meaning. There's sections, heading, body text, there's names and addresses and dates and photos, and this chart image is like a black box for the browser, right? It can't know what's inside that image. It doesn't have any understanding of what the pixels mean. So, you can't really mess with it. You can't say, like, that bar is interesting, I'd like you to expand that bar, because it doesn't know anything about a bar. All it knows is that there's pixels of a certain color at a certain point. But good news! In 1999, along came a standards body and defined Scalable Vector Graphics, SVG. At the time, it was mostly about killing Flash, which was terrible, so everyone's glad that they did it. SVG is a way to describe vector graphics, the kind that make up charts, not photos. And the most important property is that SVG content works right inside the DOM. It looks like the rest of the DOM. You can take any SVG and stick it right inside a web page, and it's no longer a black box. The same tools that you use to dynamically alter your content on a regular web page, you can use to peek inside your visualizations, if they're SVG. And you can use it to animate those visualizations and make them dance. D3, who here has not heard of D3? My condolences. D3 is a very popular visualization library. I think it's the first library that deserves the name visualization library because it's not a charting library. It's the thing they use to build charting libraries. It's like one level underneath in the stack. So D3 is an engine that takes data and spits out SVG. In other words, D3 makes it really easy to dynamically map data onto nodes in your DOM in visually meaningful ways, right? And if you've been wondering why everyone and their sexy black brother can't stop talking about D3 even when they go shower, this is why. Those objects that we talked about, right, they're just DOM nodes, right? They're just nodes in that tree. And this is why D3 is such a big deal. It married the right low-level visualization constructs with the bones of the dominant medium, the DOM, the web. No proprietary plugins, and we get to think about visualizations in the same way that we got to think about web content for the last 10 years. And the coolest part about this is that you can address every element in your visualization. So if you want to animate it, it's pretty easy. But right now, there's two dominant paths to animation on the web. There's JavaScript animation and CSS animations. So this is what it looks like to animate a dot so it appears to grow from nothing in D3, right? In JavaScript. I ask it to get me a circle, find me this circle, set its radius to 0. I'd like to kick off a transition. I'd like to wait half a second before it starts, and then I'd like it to last for a full second, and then I'd like it to end up at a radius of 10. D3 will animate this for me, will do it pretty efficiently. This is one way to go about it. With CSS animations, it's more about transitioning between states. So for example, if we wanted to hide something by fading it out over half a second, what I would do effectively is I'd define these two states of regular and hidden, and I'd define how you transition between these two states, and then in JavaScript, I'd apply the state or take away the state. So it's like flicking a switch, and then CSS does the rest. Now, these two different routes, they have pros and cons, each of them. In JavaScript, you can control everything, and some things you can only control inside JavaScript, because from CSS, you can't see the values that you're computing dynamically in JavaScript. So if you've calculated something, CSS can't see it. So if you need to do something, some animation based on something that you've calculated, you have to do it in JavaScript. And you can chain animations in JavaScript, which you can't do in CSS. But it can be harder to write, and it's a lot easier to shoot yourself in the foot from a performance perspective. CSS makes it easier to write things that are performant. It takes away a lot of the complexity, but like I said, it only works for sort of stateful things, and you can't chain it. So yeah, but it isn't an either-or situation. In production projects, you use both wherever they make sense. Some things you do in JavaScript, the things that you can't do in CSS, you do in CSS because you get them effectively for free. You don't have to write a lot of code. And I keep coming back to performance trade-offs and talking about hardware acceleration because CSS transitions are hardware accelerated. What we're really reaching for is animations that consistently produce 60 frames a second. Why 60, right? There are actually a few different factors affecting this. Mostly, it's that most screens nowadays, they refresh at 60 hertz, meaning that you have 60 frames per second, 60 opportunities to draw something to the screen every second. The other reason has to do with biology and our vision and all kinds of stuff. But there are a few different factors affecting this. The most important of which is hardware acceleration. Most computers nowadays have 3D graphics hardware, like silicon, that allows them to do games, basically. That's where it all came from. But they're basically really fast engines for calculating certain kinds of math, mainly matrix multiplications, which is what you need for doing affine transforms, 2D affine transforms. What are affine transforms? I'm glad you asked. These are affine transforms, and you get them for free when you use hardware to do your transforms. So if you're going to move something around, just move it around. Or if you're going to scale it, or if you're going to rotate it, or if you're going to change the opacity. That's not really an affine transform, but it doesn't matter. All these four operations are fast. You can do them for free. It doesn't use a lot of battery on mobile devices. It doesn't use a lot of battery on desktop devices. And most of all, it happens completely smoothly and stutter-free because the hardware is giving it to you for free. So what happens when we use animations that aren't free? Okay, this is Chrome with, oh man, you can't actually see it on this project. Oh yeah, you could see it for a little bit. So this is Chrome with paint debugging turned on. This is showing me, or at least on my screen I can see this a lot better, showing me all the places where software needed to redraw something from scratch, processing style, which is expensive and slow. Every time you see anything green flash on the screen, that's a part of the browser that the browser needed to say, stop, now I need to redraw everything that's in here from scratch, and then keep going. You want to minimize that as much as possible if you want good performance. And here you can see sort of the frame rate as it scrolls around on the different chunks. You can see also there are parts like, for example, the scroll bar all the way over here that stay constantly green. Apparently the scroll bar is not drawn hardware accelerated. This is repainted all the time. So basically all of that green repainting needs to fit into 16.6 milliseconds. Why? Because if you take 1,000 milliseconds and you divide it by 60 frames per second, that's how many milliseconds you have in order to build a frame that you're going to draw to the screen in time if you want to stay 60 frames per second. That's your budget. You need to do everything you want to do in 16.6 milliseconds or less, otherwise you get stuttering. And how does stuttering look? What happens is, if you blow through your frame budget, like what happened right here, whoops, it took me longer than 16.6 milliseconds, then I've now basically skipped a frame, right? And that looks like stuttering when you're scrolling or doing any kind of animation. So you really, really want to stay within that budget. And the reality is even worse. You don't actually have all 16 of those milliseconds for just painting. Everything the browser needs to do in order to generate a frame shares those 16.6 milliseconds of budget. So all the JavaScript, all the computation you need to do is followed by all the style calculations, which CSS styles apply where, is followed by all of the layout calculations. Where does this thing need to get painted? Should it go to the left, to the right, on the bottom, whatever. All that layout calculation happens next. And then painting, that's the green boxes that we talked about that are bad. And finally, compositing. Remember we said that hardware acceleration, you get stuff for free? This is a step in which you get that stuff for free. Compositing is like, okay, all the stuff that got painted, great, now like, you know, layer on top of it all the stuff that I got for free. So that's the compositing step. And if you're careful, you can even find ways to like eliminate stages here by not doing something that would require them. But that will also constrain your design options, so you know it's a little bit of a trade-off. Fortunately, Chrome also has tooling to help you see and profile and troubleshoot animations, right? The timeline inspector. This is a well-behaved app. If you look up here at the top, you can see at the top right, 30 frames per second, 60 frames per second. Basically, what this is visualizing is how long each frame took to draw. And if it stays below the 60 frames per second line, then that means that it rendered in 16 milliseconds or less. Okay? And you can look, here I've actually constrained it to just a couple of frames. I'm looking at them and you can see the duration it took to go through all of those different steps. The JavaScript steps, the style calculations, the layout, the painting, the compositing, and then the frame was done, and it only took 16 milliseconds for the first one. Here you can see that it's not exactly 16 milliseconds, but it's pretty close, right? So this is pretty good. But this isn't even really an ideal web app. What you really want is something that leaves a lot of room, because this is how it looked like on my super powerful, like, you know, 2014 MacBook Air, right? How does it look like on an iPhone 4? A lot shittier, right? It doesn't have as strong of a CPU. You want to build your things really defensively. You want to stay well below the 60 frames per second line if you want things to be a great experience on every computer. Now, it'd be awesome if I was done with the bad news, but that's not the way that visualization works. Everything loops back to everything, right? So, not to drag the DOM back into it, but it turns out that one of the most expensive steps in the pipeline is layout, right? There's a huge cost every time you touch the DOM from JavaScript. Because the browser needs to stop everything, like, oh my god, something is changing, I need to stop everything, change the thing, figure everything out again, and then I can keep going. So if you add, say, two different things to the DOM at two different times, you're telling the browser to stop everything twice. And that's very, very expensive. So you want to batch together your updates. And one of the cool things that's starting to happen right now, there's a toolkit called React from Facebook. It's used for generally web design, not just for visualization. But it has a new technique called a virtual DOM. And it's starting to gain traction. And the idea is that React maintains a separate copy of the DOM that is, that is virtual. And all the changes that you make only happen to the virtual one. And then once per frame, at exactly the right time, it syncs all the changes all at once. So you get like maximum performance benefits without having to touch the real DOM every time, which we know is like a speed bump. So you can see why animation is a little bit of a minefield. Collectively, the war on janky animation or jerky animation is called jank. And you've just seen like the front lines of this war that's being waged on bad performance right now. But zooming out, it's important to remember that building smooth animation is just the mechanics. It's the cost of entry. What really matters is what you do with this capability, not how it works, but what stories you can tell. Now Jeff Hare and George Robertson have a paper that's squarely about improving visualizations through animation. But what I haven't seen yet is like a well-assembled style guide, like the one that Apple and Google have authored for their respective platforms about visualization. I'd love to see something like Google's material design about visualization. Nobody's written it yet. This is something that's missing from our field, and we should probably, fix that. And unsurprisingly, the closest thing to it comes not from science, but from art, right? Two of Disney's, most famous animators in the early 80s coined the 12 principles of animation. And they wrote them down in a book that's widely known as the Animator's Bible. It's called The Illusion of Life. If you don't own this book, I warmly recommend that you get your hands on it. It's not long, it's super interesting. This is one of the 12 principles. And unsurprisingly, it's about timing. Remember that chart that we saw from Google at the beginning about the timing of how the ball moves up and down? They didn't come up with that. Disney came up with that from making animated movies for like 40 years, 50 years. They have 11 other principles. You should totally check all of them out. And there's this great website that shows them all off called the 12principles.tumblr.com. So go check it out. If you've never seen them before, make it the next thing you read about. We don't need to reinvent the wheel here. This is the map to our future. So, if driving a car was like building visualizations for the web, every driver would have to be a mechanical engineer capable of building an engine from scratch before they were allowed to get behind the wheel. Part of fixing that is spreading our load across more people than before, right? Splitting up into more specialties. But part of it is also growing proficiency with the craft and writing better tools. Some of these things we can solve with better tools. There's work happening to make the browsers better, like this tooling that I showed you in Chrome. This is relatively new stuff, and it makes everything a lot easier to do. But that's largely out of our hands. We're not browser developers. We're not going to like make this better. The place that we can have the most impact is putting useful abstractions somewhere between D3 and these really higher level things like Tableau. Things that will allow us to build the next Tableau, not things that will allow us to build another chart type in Tableau. We're starting to see this. There's tools like Vega, which allow you to skip a lot of like the D3 boilerplate, but still expose a meaningful subset of D3's power. In the meantime, go build awesome things because there's nothing better that we can do to advance our craft. And thank you.
Can we take like one question? We're like only half an hour late. Because if we have time for one question, I have one question, and if nobody else has one question, then okay. So, I think you've really given an amazing example of what does a hybrid presentation look like. You really went from like history through design, through animation, through browser performance. And there's something very attractive to me personally, both as a designer and as a somewhat technologist, definitions, and as a teacher about this idea of a hybrid, but it doesn't work for so many people. For most people, they do this one thing very well, and if they learn to collaborate with other people, they can produce much, much more than hybrids can. So that's like, and now imagine a question mark.
Does this work?
Yeah.
Awesome. Can we pull this a little over here? Excellent. So I think the answer to your question mark lies somewhere like wedged into like the space between the last two sentences. You said that hybrids are rare and that it's hard to be a hybrid, and that people who aren't hybrids who can work with other people who aren't hybrids can produce more than just one hybrid. And the key is how is it to work with somebody else from another field? Being a hybrid is not a binary state. You don't need to be a Renaissance man who can do everything for a woman. What you need is to know a little bit more about the other field. The more you know about other fields, the easier it will be to work with you. The easier it will be for you to work with others. The less communication barriers you'll have. And the less you'll need to rely on asking questions that you could figure out yourself maybe and speed things along. So I'm not saying that you should be a hybrid so that you don't have to ask other people questions. If you're a hybrid, it just smooths the communication, lowers all the communication speed bumps between you and allows a meeting of the minds where you can get shit done better and faster. So it's not now go okay, young Padawan, you've completed Computer Science 101. Go east
and train with the fabled designers and like, you know, wherever, and then come back to me like a hybrid ninja. It's not that. It's if you take the time to learn about anything outside your field, it's automatically got a lot of value, both for you in terms of like, you know, the kinds of jobs that you can reach out to get, and in terms of your ability to make things. So why not learn? In fact, there's a lot of things in computer science, like, you know, when I think about, you know, my degree is in computer science. Like, the design stuff happened accidentally. What's the value in me like learning about like design things? I think it's more valuable than a lot of the things I learned in computer science. Like, there's a million things I could learn about caching and performance and optimization, but like, what's actually going to have a more meaningful impact on the success of whatever it is that I'm building? Well, a little bit of design thinking is going to be worth a lot more than like some super deep caching knowledge. Now, there are some people that are like super deep ninjas on like one topic, they're specialists, and that's okay. But I'm saying, if you have the option and the ability to learn even a little bit about something else, there's only upside.